This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better.
I'm Sarah Talia. The stellar David Carston is away, so you've got me back in the chair. Traumatic brain injuries have become an increasingly hot topic, with more sports stars revealing health issues after multiple episodes of concussion. But what about the lesser injuries, which, when added up, could have a profound effect on the brain? In this episode, I chatted with Dr. Sarah Helliwell, a leading international expert in traumatic brain injury, who is based at the Perrin Institute for Neurological and Translational Science at Curtin University. We explored the causes of brain trauma from sports, as well as the progress of new treatments to lessen or reverse brain damage, and touched on the effects of COVID-19 on the brain. If you'd like to find out more about this research, visit the links provided in the show notes. Firstly, Sarah, what do we know about the link between brain trauma and sports?
Yeah, so it's been kind of a difficult link to find over time. We've known in some ways that people who have repetitive head injuries have long-term problems. And we've called this, even more than 100 years ago, dementia pugilistica or punch-drunk syndrome. And so this mostly came from studies of boxers who they noticed were having repetitive hits to the head, and then many years, even decades later, they were having kind of features like Parkinson's. They were having a lot of problems with their thinking and their memory. They were quite slowed. They had gait disturbances. And so we kind of didn't really think too much of it. We kind of thought, well, that's what you get for being hit in the head a lot. But it's only been in the last few decades that we've started to see this more in contact sports. With football, we've seen it here with our own football, with rugby. And we tend to only study this in the context of sports, these long-term outcomes, because there's a lot of people playing contact sports. So these are the largest population that we have to study. So it seems really like we are starting to see that people who have long histories of repetitive hits to the head, sometimes, not always, but sometimes will have changes in their cognition, their thinking and their memory, their attention, their impulsivity. They'll have problems with their emotions. They'll be often depressed, have anxiety. They'll be unable to regulate their impulse control, so they'll be quite irrationally angry, and they'll have angry outbursts and things like that. And we see more anecdotally that has effects on their family. They're splitting up with their partners. They're estranged from their friends and their kids, and it's very difficult to kind of characterize this because these are all kind of quite general things. They overlap with a lot of things like Alzheimer's, Parkinson's, mental health conditions. And so it's really only when people have passed away that we can see the real pathology in their brains that signifies what we call chronic traumatic encephalopathy, or CTE.
And what are some of those signifiers? What are you looking for?
Yeah, so there's accumulation of a protein called tau, and tau is part of the white matter structure. So it's part of the neurons that helps to give them support. And it's a protein that can kind of form these plaques. So we think that the axons, so the tails of the neuronal cells that send the information around through the brain, that they become damaged and they form in the base of the ridges and the bumps in the brain, the sulci that's called. They tend to form in these aggregate kind of plaques in those regions.
So you mentioned, historically it was often those really high contact sports like boxing, but what about microtraumas? What about those smaller hits? What do we know about that and leading that potentially to long-term brain damage?
Yeah, that's a great question, because we tend to only recognise the hits that result in concussion, because if it's not a concussion, then what is it? But we're starting to see more and more evidence of what we call subconcussion or subconcussive hits. And these are the ones where you've had a hit to the head, maybe your head has rotated a little bit as you've had a hit as well. We know that the angles and the rotation is also important, but there will be changes potentially in very subtle pathological changes in the brain, but it's not enough to result in symptoms. So we don't have, when you have a hit to the head, we don't have dizziness, we don't have vomiting, we don't have confusion, any of those kind of classic concussion symptoms. But we think if you have a lot of them over time, then that could be just as bad, if not worse, than having 1 or 2 or 3 concussions. So we're starting to see now studies of soccer players, because they're heading the ball all the time and they're having these kind of repetitive hits. In practice, they'll be heading the ball 50, 60 times, 3 or 4 times a week, and then in games as well. And so we're starting to see more and more evidence of this kind of behavioural changes long-term in soccer players, and especially sort of now in women as well.
And gender does play a role in this space. Why are women twice as likely, I'm told, as men to develop sports-related concussion?
Yeah, that's right. So we don't know exactly why it is. So some people say it could be that women have different musculature in their neck and shoulders, so they're not able to hold their neck up as well. But that actually doesn't seem to be true. There's been a few studies disproving that. Then other people will think, well, maybe it's because women take up contact sports a bit later, typically than men. Not so much now, but it has been historically that women haven't played contact sports as much. So if someone was, for example, taking up AFL now, they might be starting in their late teens, and so they haven't had that history of learning how to tackle and how to fall in a safe way. But now that we've got more and more women playing football and contact sports from a young age, that also doesn't seem to be true. So now we're starting to see, is it something in the brain itself that's making women more likely to have concussion? And there's been a few recent studies that show these structural proteins in the brain are different in men and women. So these have been shown in animals and in humans that the white matter bundles are thinner in women, in females, and there's less structural proteins. So if you've got less structural proteins in a woman compared to a man, and she has a concussion, then she might be more prone to damage, whereas the man might have also damage, but he's got more structure to compensate for that.
So you've touched on a few of them earlier, but what are some of the key symptoms to be aware of when it comes to sports-related brain trauma?
Yeah, so we often think you need to be knocked out to have a concussion, but that's not true. You can have a concussion without being knocked out. You can have a concussion without vomiting or dizziness or any of those really overt signs. You don't actually even need to hit your head to have had a concussion. You can have a blow to the body that exerts enough force that your brain is moving in such a way within a head that you're causing a concussion. So some of the classic symptoms we tend to see, aside from those really overt ones, are headaches, confusion, difficulties with memory. People sometimes will have a little bit of amnesia of the incident itself or within the hours that follow the concussion. Sometimes it's things like just feeling really sleepy or not sleeping well. People might feel depressed or emotionally labile. They might just feel really kind of emotional for no specific reason. They might feel anxious, but not everyone will have all the same symptoms, and not everyone will have their same symptoms every day. So it's really hard to, unless you're aware of all the symptoms, there's about 22 common symptoms. So, you might have one, I might have 2 others, someone else might have 3 or 4 completely separate symptoms. It's really hard to characterize what those symptoms are and what that presentation is like. It's really different and individual for each person. So we often say, if you've seen one concussion, you've seen one concussion.
And as you well know, there's been a lot of media attention in this space recently. It's really been mounting over the last few years, and it feels like it's been coming to a head over the last couple of months. Are there any recent reports or research that's really stood out to you?
Yeah, there's been quite a bit actually. So there have been in the last couple of years the first studies that have come out in Australia on CTE in our sports. So we have our own football code, our AFL. We've seen AFL players have passed away that we've seen the classic pathology in AFL players. We've seen it in rugby players. We're now starting to see it in soccer players. We're seeing it in female AFL players. And there's been a paper that just came out in the last couple of days that was looking at younger people. So we tend to see that people will have these injuries when they're young, and then it'll be decades until they pass away, and then we'll look at their brains when they've passed, and then we'll see this pathology. But one of the things, as I was saying, that people often have emotional problems, and unfortunately a lot of people will commit suicide or have unintentional drug overdoses and pass from that. And so there's a brain bank in the US that's been collecting donated brains that their families have donated. And these people all were contact sports players for various years, 3 or more years of contact sport. And they were all aged under 30. So I think the youngest was 13, the oldest was about 30. And they found that 40% of those people who'd passed had evidence of this CTE pathology in their brains. So they didn't have, because they didn't study these people when they were alive, they didn't know, do they have the symptoms when they're alive? Do they have, they couldn't do formal tests to show was their memory declining to such a rate, or did they have any other cognitive problems? But a lot of their families had self-reported that they did as well.
There's some pretty startling figures there.
Yeah, that's right. It really makes us think that we don't know much about this at all, and we really need to do a lot more research.
Do we know, and this is, I feel like a bit of a long shot, but do we know how many hits? Do we have an idea of how many hits it takes to actually cause long-term brain damage?
We really don't. I wish we did, but we really don't. So some people can have one concussion and that can really affect them for many months or years. And some people can have multiple and they can be just fine. So it doesn't seem to be the number of hits or even the number of subconcussive hits. It could be, I mentioned before, the angle and the rotation. If you're falling especially, rather than being hit directly in the head, that could have some effect. So it might be that the way you fall or the way you land could have an effect. It could be the part of your head that you hit, but we really don't know.
You've also commented on research indicating that COVID is actually accelerating brain damage, a really interesting space. Is that linked to the brain fog that some people have been experiencing after the kind of main event of the COVID illness?
Yeah, well, it's interesting that you say that, because these are people who had COVID and had recovered mostly well. So this was a study that was conducted early on in the COVID pandemic, before the vaccines were introduced. So we don't actually really know what the effect of vaccines are in reducing that brain atrophy or loss of brain tissue volume. But in a large study, there were thousands of people in the study, it was shown that having COVID infection can reduce brain volume overall, which is quite scary to think about.
It's very scary. And also, again, a really interesting time for the research in your space and around it, for just how much potential there is in helping us understand impacts from sport and impacts from, a virus that's caused a massive pandemic.
Yeah, absolutely. And the really interesting thing for us is that what we call post-concussion symptoms, or persistent post-concussion symptoms, these are people who don't recover well from their concussion and have long-term problems. We know maybe, depending on the study, about 10 to 50% of people will have persistent problems after concussion. That kind of constellation of symptoms that people might have early after a concussion, they persist. And that's almost exactly the same as the long COVID symptoms as well. So people are having fatigue, they're having brain fog, problems with their memory, they're having emotional problems, they're not sleeping well. So something is happening in the brain that really seems to be common to both of these illnesses, but we don't quite know what it is.
Space for a lot more research there.
Right.
We're just going to pause for a quick break. We'll be back right after this message.
New diseases and the steady increase of the world's population have highlighted the growing need for healthcare experts. At Curtin University, our flexible postgraduate programs are taught by industry leaders and mix theory with practice to allow you to become a skilled and caring healthcare professional, even if you've never studied a health degree. Depending on your program, you'll have the chance to work on real research initiatives with an industry partner or take part in a practical placement at a student-run health clinic. Get started on your postgraduate journey today by visiting curtin.edu/postgrad.
And we're back. Sarah, your research is focused on brain injury. Why are you interested in this space?
Yeah, I'm really interested in brain injury from an early age, because I had a friend who had a brain injury, and she had quite a severe brain injury. When she came back to school, she was academically fine. She was still really good at sports and everything, but her personality was completely different. So she went from being very shy, very introverted, to be very outgoing, having a lot of kind of outbursts in class, interrupting. And I just thought, how can this be? How can someone completely changing their personality from an injury. And as I went to university, there was no neuroscience course. I'm not that old, but there was no neuroscience course when I was at university. And but I studied a lot of neuroscience through immunology and microbiology, and kind of learnt how things affect the brain and how the brain protects itself, and got really interested in it. And I'd had a few concussions as well through sports. I used to do a lot of snow skiing, and I'd had about, I think, 5 or 6 concussions by that time, and I was mostly fine afterwards. But I was so interested in that and how concussions can affect the brain. And so that got me really interested when I was at uni. And then I got the opportunity to do my honours degree and then subsequently PhD in a lab that studied brain injury from multiple different perspectives. So what the long-term implications are, can we develop biomarkers, so markers in the fluid, the blood or the cerebrospinal fluid, to try and predict how people recover, and how we can understand things like the inflammatory response after brain injury.
And is that part of what you're researching right now?
Yeah, that's a lot of what I do now. So I work across the whole spectrum of brain injury. So I work from the mild traumatic brain injury or concussion side up to the very severe kinds of brain injuries where people will have prolonged stays in hospital. They'll need a lot of rehabilitation. And unfortunately, we've gotten very good at keeping people alive after they've had a brain injury. That's the good part. But unfortunately, we don't have a treatment for brain injury. So a lot of what our research is focused on is understanding potential drugs, potential therapies we can use to prevent that initial damage and have better outcomes.
I can imagine at a barbecue when you talk about, when someone asks you what do you do and what are you researching right now, you must have quite a lot of people with their own experience or know someone who's experienced a brain injury. It seems to be a lot more common than most of us realise.
It's much more common than we realise. In fact, 1 in 5 of us will have a brain injury in our lifetime. So, as you say, everyone knows someone who's had a concussion if they haven't had one themselves. Most people will know someone who's had a more serious brain injury as well. It's so much more common than we realise, but also because it's a silent injury, an invisible injury, we don't often recognise it. And that can be hard for people when they've had a brain injury. If their personality changes, they can find it really difficult to be in large groups because they can't focus their attention and their hearing. They might feel overwhelmed a lot more. Their relationships will change a lot, and that can be really hard for them, and it can be hard for their loved ones as well to understand that because, once they've recovered, that, a couple of weeks or months after injury, they think, well, you're better now. You're no longer in the hospital. You're no longer having physiotherapy. Surely you're back to normal, but that's the new normal for that person.
When you mentioned silent injury, that's really in some ways at least shifting a little in that there has been a lot more attention on brain injury and trauma and concussions given the recent media attention. What is that like for you to have your area of research interest kind of in the headlines? Yeah,
it's really great. I think this is an area that is really poorly understood. And it's an area that there's not a lot of public awareness about. So a lot of what we're doing is trying to educate the public about, if you've had a concussion, what does a concussion look like and what should you do? There's not a lot of information or there's a lot of conflicting information about how you should manage it, how you should go back. And one of the main things we always say is, if in doubt, just sit out. So if you're playing a sport and you have a concussion or you think you've had a concussion, you've hit your head in a way you don't feel quite right, just go off. Don't keep playing, because that can really exacerbate the damage to the brain.
And beyond that, what can we do, and what can athletes do, and maybe even clubs and rule makers do to help better protect people from brain trauma in sports?
Yeah, so we don't want people to stop playing sports. There are so many positive benefits to sports, apart from fitness. There's particularly contact sports like football. There's a great culture at the clubs. There's a lot of positive support for people. That's a lot of their social interaction. But we want people, if someone has a concussion, to come off the field and not go back to play again until they're really ready. So they're having the proper assessments to go back to make sure that their brain's healed and they're ready to go back to play, because we know that the damage to the brain will extend past the time that the symptoms recover. So we need people to, really take it easy before they come back to play. and for clubs to be really aware of it and support people and talk about it more openly. So it shouldn't be a shameful thing. It shouldn't be an embarrassing thing to have a concussion. It should be something that we're open and frank about and we take people's health seriously.
On that, at what point do you think people should be reaching out to their doctor?
Yeah, if they have any concerns whatsoever, it could also be a good thing if people are, they're playing contact sports and they're always going to be at risk of concussion, then to just be in more regular contact with their GP, have a checkup every year or so, and if they've had a concussion, go and get checked out, just so that their GP is aware and can keep an eye on it.
Sarah, you've received a lot of grants, and there was one that you've received recently. Can you tell us about that and what you hope to actually do with the funding?
Yeah, sure. So we were lucky enough to receive a Medical Research Future Fund, or MRFF grant, for a project called AusMTBI. So this is an Australian concussion study that's got two parts. The first part is a phone app that people can use to track their own symptoms and monitor themselves when they've had a concussion. So that is just about to come out. That's going to be freely available for anyone around Australia to use. And then as part of the same grant, we're going to also have here in Perth and in Brisbane and in Melbourne, people who come to the hospital after they've had a concussion will be asked to participate in a study where we'll be doing very, very high quality research MRI scans. So these are scans where we'll be able to see a lot more into the brain, that really kind of subtle pathology that we can't see in a clinical scan. And we'll be doing blood samples and we'll be doing cognitive tests and balance tests and things like that. And we're aiming to recruit about 200 or so people across this study so we can really understand what's happening early after injury. And then we're going to follow these people up for a few months after their injury to see how they recover, if they recover well, and if they don't recover well, why not? And can we try and predict their recovery from their early injury data?
This year, you received an award from the Australian Institute of Policy and Science for excellence in research and communicating science. And I'm not surprised you did. What motivates you to talk about the incidence of brain injury that's occurring in the community?
Yeah, so this award is called a Young Tall Poppy Award, and it, as you say, is awarded for both your research and for your community engagement and outreach. And I am very passionate about brain injury and very passionate about people's brain health. So this is something I'm really interested in talking about with people. So I like to go to sports clubs and things and talk about brain injury, talk about how we can be aware of our brains and the effects of concussion, what a concussion might seem like, get the facts straight about what is and what is not a concussion, things like that you don't need to have hit your head to have a concussion. Most people don't know that. That you don't need to have hit your head or don't need to have lost consciousness to have had a concussion. And I also do a lot of outreach work with military and veterans as well who've had brain injury, and they often feel quite isolated. They've got no one to talk to about it. They don't, particularly with veterans, once they've left the military, they've lost that support, they've lost that camaraderie. So talking at veterans organisations helps to kind of normalise talking about concussion and talking about how your brain might not be as good as it once was and what we can do about that and how we can, feel a bit better and making people realise that it's okay to not be okay.
I can imagine, I can really see you making that bridge between lack of understanding and assumptions, but also for people that have experienced brain injuries and people around them that don't understand some of the responses they're having. That must come as a huge relief sometimes when you're able to provide language and understanding.
Yeah, definitely. So one of the kind of big outreach things we do as well is to family and friends and people who are around other people who have brain injuries. So through Connectivity TBI, that's a West Australian company, but it is a national service. It's a charity that aims to do exactly that, provide information on brain injury. And they have a few short courses that are free for anyone to do that give information about what a brain injury is, what it looks like, and how to kind of adjust your expectations if you're the person who's had a brain injury, but also if your loved one has had a brain injury, and how to be more understanding and supportive of that.
Thank you, Sarah, for coming in today and sharing part of your story and helping us to kind of better understand the space you work in and a topic that really impacts so many lives. Thank you.
Thanks so much for having me.
You've been listening to The Future Of, a podcast powered by Curtin University. As always, if you've enjoyed this episode, please share it. And don't forget to subscribe to The Future Of on your favourite podcast app. Bye for now.